Chapter 3 with routers and the concept of routing. Okay, it's correct that the name of the chapter is IP connectivity, but IP and IP addresses are a layer 3 technology, and routers also are layer 3 technologies. So by name, chapter 3 is IP connectivity, but what will really happen, the real scenario is that chapter 3 will be all about routing, routers, and the routing protocols that we will apply and configure on the routers that we will use. Okay, so the concept of switching and switches were some simple devices that you can take them out of the box, operate them, and connect your devices to the switch, and they will work correctly and directly without any configuration needed. Okay, for VLANs and spanning tree, some configuration might be applied. In the routers, there is nothing called take a router out of the box and operate it. It will not operate correctly. It will not function networking correctly. Okay, because of two things. The first one is that all the ports or interfaces of a router by default do come in the shutdown state. They are the state of the ports are down. So you must unshut it. You must enable each single port separately. This is the first point. This is the first point. The second point is each single interface, as I have mentioned before, each single interface of a router is considered a single separated broadcast domain or a single separated network. So if one interface is considered an entire separated network, then when I operate a router and connect two computers, maybe two devices to the router, they will not communicate because the ports are down and each one of them is considered a separated broadcast domain. So then I must do two things. The first one will be to unshut the ports. The second one will be to use routing protocols to route the packet from device number 1 to device number 2. Okay, so device number 1 that I'm talking about is this is a router and it's connected to two devices, number 1 and 2. So it's connected to this interface. Maybe it will be fast Ethernet 01, and this interface that will be maybe fast Ethernet 02. Okay, so the first thing is that I must unshut these ports, and the second thing is that I must apply a routing protocol to route the packet that comes from this device, enters this port, to this port that will exit to this device. Okay, so this is the concept of routers and how do routers operate or function. Routers by default, they isolate each single interface alone, so you must route between them. That's the first thing. And the second one, that you must unshut ports. Okay, but the good thing is that when I have a router and this single interface of a router is connected to switch, and these switches have some end devices connected to them, this is a broadcast domain. This is an entire network alone. Okay, so these devices, if they were on the single subnetting, have the same IP addresses from the same subnet, they can communicate together without the need to go to a router. But just in case they wanted to talk to another or communicate with another network, that maybe this other network is in here, at that time they will need to cross through the router to the other one. Okay, so but you must notice then the IP address and subnet mask in this network must be different than the IP address and the subnet mask of this network. Okay, so I used 192.168.1.0/24 for this network. Then at least this one might be the next, which will be 192.168.2.0/24, maybe for this network. This subnet is different than this one. They cannot communicate at all, but having a router will make this subnet be able to talk to this one. Okay, so this is the concept of routing, that it can connect two different subnets, two different prefixes, two different networks together. And also this is done by using routing protocols. Okay, so what I have just talked about is having a router with two interfaces. Okay, with two interfaces, and once the router receives a packet from this interface, and this packet should be forwarded to this interface, so the router will do the forwarding. The router will do the forwarding process, do the forwarding procedure based on which criteria or which procedure exactly. That is what we will talk about in our first subject in this chapter, which is the forwarding decision. How do the router takes the decision about forwarding this packet that I have just received on maybe interface 01, and this packet needs to go to interface 02. How should I forward it and to take the packet from this source to this destination? Okay. So as a router, I do separate broadcast domain. We have received this. When receiving a packet, it stops at the interface. Okay, you remember switches. When switches receive a broadcast message on an interface, what will happen? You should have known by now that it will forward this message directly to all the other interfaces except the interface that it received the broadcast message from. Okay, so all the interfaces of the switch are up and running, all of them are forwarding messages, and this will cause a mess. Okay, but in routers, once a router receives a message or receives a packet at an interface, it stops right there. Then it will be shown to the engine of the router. It's either to be forwarded to some single, maybe to some specific route or some specific destination, or it will be dropped. Okay, so it stops at the interface. Routing will decide how to forward or how to route. Maybe you can call it a route, but I believe in the English language, the original English language is called route maybe. Okay, how to route the packet. Okay, in the matter of three steps or three concerns that the criteria of forwarding will take. These will be: first, let's check the longest match for this prefix. What do you mean by longest match? Let me tell you, the longest match is how much the IP address and its subnet mask of this IP address is matching the available options, or it's matching the required specific destination that the packet must reach. Please explain more. That will be in the matter of, in my router, there is something that's called a routing table. If you remember MAC address table of switches, which switches use for forwarding frames to forward packets in routers, there is a routing table instead of a MAC address table in the switches. Okay, so what will a routing table do is that it will have the routes installed, and we will see this in a few moments or a few minutes coming. Okay, the routes installed already in the routing table. So once a packet is received on an interface, the router will directly check the routing table and see that this packet came from maybe this device and it wants to go to this device. This device IP address will be 10.10.10.10, and it wants to go for maybe 10.10.11.10. Okay, so the destination of 10.10.11.10 must be at least either this specific destination or the network of this subnet of this host. One of these two must at least be installed in the routing table. So once the router receives a message or a packet that requires to reach this destination, then it will say yes, this destination, which is 10.10.11.10, can be reached by forwarding the packet to interface maybe 02, and this is how will the router take the packet and give it to interface fast Ethernet 02, and it will get forwarded to the required destination. Okay, so you must manually install and let the router knows how to reach the subnet of 10.10.11.0 or the host of 10.10.11.10. okay, this is not clear enough. This is 11 and this is 10. Okay, so the longest match for the prefix is that what I will say, or what I'm meaning is that will be the longest match will be, imagine if you have installed or mentioned the prefix of 10.10.11. something more than one time in the routing table. Maybe you have just mentioned that route 10.10.11.0/24 to maybe fast Ethernet 02, and route 10.10.11.0/ maybe 28. This is a smaller subnet than this one. Okay, you must notice that this one is much smaller than this one. If this one gives me 254 IP address, then I must divide them by 4 because I have moved 4 steps: 24, 25, 26, 27, 28. Okay, that is just some extra blah blah that I'm talking about, just to know how much these will give you. Maybe 254 divided on 4 will give 64 subnet available in this prefix, in this subnet. Okay, so this is the other option of 10.10.11.0/28 through interface maybe 03. And lastly, there is a route of 10.10.11.10/32. whenever you see an IP address that has the subnet mask of /32, it's 100% to be a host. The device itself, the IP address of the device, of the end device, or of any networking device itself, once it has the subnet mask of 32. So my router just received a packet from the source 10.10.10.10 wanting to reach the destination of 10.10.11.10. Okay, so it will look to the routing table and it will say that 10.10.11 is common between all the three of you, but this is .0, this is .0, this is .10, and this is not really important because IP address is a very useless address without the subnet mask. Okay, so my packet wants to reach a host, and the host has the subnet mask of, I have just mentioned, 32. Okay, so when I come here, this matches only 24 out of the 32 that I want. This one matches only 28 out of the 32 that I want. This one matches the entire 32-bit of the 32-bit that I am requiring to reach. So the routing table and the router will take this route, this installed route in the routing table, and use it and use its next hop, which is maybe 0/1, to route the packet to the required or specific destination. So this is the first thing to check. These are not or. No, all these steps will be applied gradually and step by step for each specific route starting from now. Okay, so this is the first check in the procedure, is that I must check the first long or the longest match that I will take. After that, inside the routing table, each one of these routes has a specific routing protocol assigned to it. Okay, so just the first thing that I'm asking you to is to understand the longest match criteria. Okay, this is the first thing. Let me clear the screen. The second thing is that after knowing that I will use this specific route, okay, then we will look at, decide which routing protocol should handle this task. In the new CCNA exam, there is only one routing protocol, or maybe there will be two routing protocols that you will deal with. The first one is the static that we will take in this chapter. This is the static route, and the second one is the open shortest path first routing protocol. Okay, before, in the past, in the previous CCNA, there was static, OSPF, RIP, EIGRP. These are inside your network, and outside of your network there was BGP. This is outside of your network. Okay, so there were 5, now only 2 left. Okay, Cisco wants you to know only these 2. So this one is a static protocol, this one is considered as the dynamic protocol, and we will talk about 2 of them in detail, okay, in the upcoming slides and videos. Okay, so without further talking, so first one is the longest match. The second one is that which routing protocol should handle this task. Maybe you have just mentioned 10.10.11.10/32 in the routing table twice or 3 times. Maybe you have mentioned this host to be routed using OSPF or static or EIGRP or RIP. Maybe you have just mentioned them, all of them. You have routed this destination manually by yourself, but you have repeated the command 4 times, each time with a different routing protocol. The reason that there are multiple routing protocols like RIP, OSPF, EIGRP, static, and BGP is that each one of them has what's called a metric, its own metric, that this protocol was designed based on such algorithm, and based on this algorithm, this routing protocol takes this packet or whatever packet that is required from it, and it will route it or forward it based on maybe such criteria or such algorithm. Maybe like these cases will happen when you have, this is getting slow motion. Okay, I think we have a problem in the processor. Let's check. Okay, so when I receive a packet from this interface and it wants to reach here, this area, it's either I forward the packet from this to this router or to this router. Okay, so the reason for routing protocols is that some routing protocols will measure the bandwidth of this link and the bandwidth of this link and the bandwidth of the entire route from this way, and the bandwidth for the entire route from this way. It will take the best bandwidth and route it to it. Other routing protocols maybe will say that from this path there is only a single router to reach the destination. From this path there are 2 routers to reach the destination, so I will take the shortest path like OSPF. Okay, OSPF do use bandwidth, okay, but has this name for the criteria of building the tree. Okay, maybe in RIP, that previous protocol, the routing protocol, it was considering the shortest path, the shortest hop count to take. In EIGRP, it has some complicated formula of measuring all the details for the available paths, and after that it will route the packet on maybe 1 or 2 of the available paths at the same time. It will make the use of 2 of them. Okay, but now you have this criteria of more than a single path, which one should I use, and all of this that we are talking about happens only with the dynamic routing protocols. Okay, because in the static routing protocols you by yourself do assign and do route the packet and the subnet or the prefix from a specific destination. Okay, in static route, which we will see in the upcoming video, you tell the router that to get to 10.10.11.10 do go this way and this way. Okay, in dynamic you just advertise this subnet or this prefix, and let the router using the routing protocol to decide from which path should the packet be routed. Okay, so what decides that which routing protocol will win from all these available routing protocols, that all of them can give me a service or can give me a help and route my packet, is something called the administrative distance, as known as the AD. The administrative distance is a value that each routing protocol has. It's a numeric value that each routing protocol has, and this will be the protocol and its AD. If something was directly connected, and we will talk about this in the lab, then it will has the AD of 0. If it was assigned or routed using the static, then it will has the ID of 1, or if you were using the OSPF, it will has the AD of 110. The moral of this story is that when two or more routing protocols have competition between them to route a packet, the one with the lowest AD wins, and the router will rely on this specific routing protocol to route this specific packet. Okay, so in the case of OSPF and static will win because it has the AD of 1. So the router did decide which protocol will handle this. After that, the desired protocol will submit its own rules or metrics to route the packet. I told you, some protocols like RIP will take the shortest path. Okay, that's because of the path sometimes jumps to the shortest, just like I said it. Okay, so the shortest path, like if I was using a RIP, just don't consider RIP, don't confuse it. It's out of your new CCNA blueprints. Okay, so when using RIP will say if I go this way, it will be one router to reach the destination. If I went this way, it will be two routers to reach the destination. So I will take the shortest one. Okay, using OSPF will check the bandwidth of the method. Maybe you'll see that the bandwidth of this route will be only 100 megabit per second, the speed. Okay, here, but the speed or the bandwidth in this method is 1 giga or 1000 megabit. Okay, so this is 10 times better than this path. Okay, yes, it's a longer route or longer path, but it's much faster, so I will take this path. This is for OSPF and this is for RIP. Each one of them have its own metric, that using this metric an algorithm will be applied to the path or to the topology. After that, the protocol will decide which path should be used to route the packet. Okay, so this was only the concept of routing and the forwarding decision, which is the most important thing that a router do. The forwarding decision is to decide how to forward the packet. This is your biggest concern when using routers to route packets, is that you must know how will the router forward each packet or each network or each host using, which path or which routing protocol, because after that it will get more complicated and you must know which scenarios will happen in your network. Okay, so this is only the talk about the concept. After that, we will jump to the two protocols that you must know in this exam, which are the static route and the open shortest path first, the OSPF. Okay, so in the upcoming videos, we will start with them. See you at that time. Thank you.